Hello, my name is Keyon Vafa, and I'm a computer science PhD student at Columbia University, and I will be discussing text-based ideal points. This is joint work with David Bly, who is my PhD advisor, and Suresh Naidu, both of Columbia University. To give a brief outline of the talk, this is a work in progress. So after defining ideal points, I'll discuss text-based ideal points, which is a method we've been developing. I'll discuss our applications to Senate speech data, and also our initial work on judicial data using CAP. So an ideal point is a way to capture someone's ideology with a single number. So this graph, for example, shows the ideology of Supreme Court justices. And ideal points are fairly common. There's a very standard way of doing them. This is from the New York Times, and this shows how the judicial ideology evolves over time, where a more positive number corresponds to more conservative, and a more negative number corresponds to more liberal justices. The most common ideal point method used is known as the Martin-Quinn score. It's a Bayesian method to measure the ideology of justices, and it's based solely on the voting record of each justice. So because it's based on the voting record, these same methods can be used for senators, for congressmen, essentially any entity that votes. And it varies smoothly over time, like we saw in the last slide. So these are ways essentially to analyze votes on shared cases to infer ideology, but there are limitations. Because these are based on votes on the same cases, we cannot compare judges on different courts. And moreover, votes on decisions must be available, which is easy for the Supreme Court, but is not as easy for lower-level federal courts or for state courts. Our solution is to use text-based ideal points. That is, analyzing the language of opinions that judges write to infer ideology. Language, or the English language, is shared across the American judicial system. So we should be able to compare judges on different courts, single judge panels, anyone who writes opinions. Now I'm going to pivot a bit and discuss ideal points for senators, but these are essentially the same ideas. Instead of voting on decisions, we have voting on bills. Instead of written opinions, we have written Senate speeches. So to give a repack on vote-based ideal points, which is the same thing as the Martin-Quinn score, I'll use those words interchangeably. In comes a voting record of each senator, how they voted on each bill, and out comes a list of ideal points, which map all the senators from their ideology. For text-based ideal points, which we've been developing, we don't take as input the structured voting data, we take as input speeches. Nothing about party information, nothing about votes, just speeches on the Senate floor, which could be about anything from Trump University to Medicare and Medicaid. And out we hope to, or we do, these are actual results we have, which I'll go into in a bit, we output ideal points that map senators on the political spectrum, and topics, ideological topics. And these capture how different people talk about the same thing, adjusting for their ideology. So someone in the middle might discuss the Middle East using words like ISIS, Syria, war in Iraq. Someone on one end of the political spectrum will use words like refugees, war, Muslim million, and someone on the other end will use Obama, presidents, terrorists. And again, I want to reiterate, we don't know anything about ideology. All we have are these bag of speeches. So to give some intuition for our method, we noticed that when discussing a topic, word choice is skewed by ideology. So for example, take abortion. On abortion, there are going to be words that everyone uses, regardless of ideology. Words like pregnancy, abortion. Then there are going to be words that are sort of co-opted by different sides, like life and choice. And we can think of the words that each person uses on a shared topic as a sort of vote. They're not voting on bills, they're voting by using different words when discussing the same topic. So for vote-based ideal points, we can infer ideology by vote differences on shared cases, but for text-based ideal points, we can infer ideologies by word choice differences on shared topics. And we don't have information about topics. We don't know, this is when Mitch McConnell is discussing abortion here, or Elizabeth Warren is talking about Medicare and Medicaid here. These all have to be inferred. So, for example, a standard topic model may infer these topics, one about abortion, one about healthcare, one about rights and freedom, but our model is able to infer how these ideological topics, for example, one side discusses abortion in terms of the unborn and life, and one side discusses abortion in terms of women and care and access. I've colored them red and blue because they correspond to our intuitive notion for how Republicans and Democrats, Republicans in red, Democrats in blue discuss these topics, but the model doesn't know that. Similarly, for healthcare, one side uses words like Obamacare and Obama and care, and the other side uses words like the Affordable Care Act. And for rights and freedom, one side discusses religious freedom, the other side discusses civil rights and racial equality. Briefly going over the model, the only data we use is word counts. Again, no information about party, no information about votes. We have Yij, which is the number of times that word J is used in document I. Sort of like in a standard topic model, like LDA, for those of you familiar with it, we have a decomposition. Theta captures the frequencies of each topic in a speech, and beta captures the top words for each frequencies. This is similar to LDA. We've done nothing here for ideology. Our difference, though, is that we add a term eta, which is an ideological topic. This captures the deviation from the normal topics from LDA that each person uses when discussing a topic. Again, these are all learned. We don't have any of these a priori, and the degree to which someone's discussion veers from the neutral topic is dictated by an ideal point, XS, one for each senator. Just in the bottom right-hand corner, this is the mathematical model we use. When x of SI, that is the senator's ideal point, is 0, it's a very standard matrix decomposition like LDA. When it's positive, the words that are emphasized are the positive words for A to JK, and when it is negative, it kind of flips, and so the negative words for A to JK are emphasized, and that captures how the different ideologies discuss topics. So the data we fit is on the 114th session of the Senate. It says 2016 to 2018, but it's actually 2015 to 2017. There are about 10,000 words in the vocabulary, and there are 100 senators. We train the model using variational inference with stochastic optimization. Don't worry too much about the technical details. The fitting details are a little bit technical, but I'm happy to discuss them offline. So our results. For senators, the model learns these ideal points, and for those of you not familiar with the parties, I've colored them all in terms of red and blue and have noted their political affiliation. So the model is essentially able to take just these bags of unstructured, unordered, and unlabeled speeches and generate a political spectrum where Bernie Sanders and Elizabeth Warren are on one extreme, Mitch McConnell and Marco Rubio are on the other extreme. In the middle, we have people like Claire McCaskill, Jeff Flake, and Susan Collins. And it's able to adjust topics based on positions on this spectrum, where in the middle, again, someone like Susan Collins may use women, Planned Parenthood, and care for talking about abortion. Someone on the left emphasizes women and care, and someone on the right emphasizes unborn life and child. So to give a recap, vote-based ideal points, which is the standard, cannot compare people voting in different settings, like judges on different courts, and we've been developing text-based models to learn ideal points and ideological topics solely from texts. And we hope to apply these on also non-voting entities, like candidates running for president or op-ed columnists. Of course, we're here today because we're interested in case law, and we would ultimately like to use our model to understand the ideology of judges. But our model, trained on Supreme Court opinions right now, learns the chronology of justice tenures rather than their ideology. So this is saying that the biggest differences in the way people speak isn't ideological, rather it's temporal. And we've seen already a couple of talks about this today, so this makes sense. The way we talk about birth control 100 years ago is very different from the way we talk about it today. So an extension is adding a temporal component to account for this and extending the model to multiple courts, also fitting on more data sets like debate transcripts for political candidates, and lastly, comparing text-based ideal points to vote-based ideal points when we're available. We can use this to discover people who, when they write or talk, they use sort of moderating language but vote very ideologically extreme, or vice versa. Thank you, and here are our references.